Hi folks, in today's video we are going to be introducing bonding and looking at ionic bonding. So there's three different types of bonds. We have covalent bonding, which is between two nonmetals. We've got ionic bonding, which is between a metal and a non-metal, and we have metallic bonding, which as the name suggests is just between metals only. Today we're just going to be looking at ionic bonding, which is the second one on the list here. So ionic bonding is when a metal and a non-metal atoms combine. For example, sodium chloride, which we can write as NaCl. If you have a look in the data book, you'll see that sodium is your metal and chloride, which is chlorine, is your non-metal. So unlike covalent bonding, which we'll learn later, ionic bonding is when metal atoms lose an electron to form a positive ion. So if you have a look in sodium here, you can see this little electron is on its own. And then when you go to the sodium plus ion, this electron has completely disappeared so that you're left with your Na+. So the opposite of that is your non-metals. They're actually going to gain electrons. They'll form negative ions. If you have a look at chlorine, you'll see we've got this lonely one here with the electron arrangement 287. So it's going to gain an electron to form 288, so a minus ion. So those two steps happen simultaneously to form an ionic bond. So if we take sodium chloride, like I mentioned at the start, you've got sodium, so we're just looking at outer electrons here, with its lonely electron here. It's going to donate the electron to chlorine, so that sodium forms a plus ion and chlorine forms a negative ion. So why do we do that? So atoms form ions because they want to have what's called a full outer shell. So with sodium, it's going to lose an electron to get rid of it, whereas chlorine's wanting to gain an electron. So that means chlorine's left with 8 outer electrons and it's relatively happy. So a definition of an ionic bond is what I've got at the bottom. So it's electrostatic attraction between positive and negative ions. Now that phrase electrostatic attraction just means attraction between charges. So it's to do with like your plus and minuses. So ionic bonds don't form simple structures, instead they form giant lattices like we've got in the diagrams here. It's like huge structures where there's lots and lots of atoms joined together to make big structures. Here we have some examples of ionic compounds. We've got sodium chloride, lithium bromide and calcium oxide, and we've got our melting points at the side. If you can see, these are quite high, and what that means is ionic bonds are nice and strong. What that means is it takes a great deal of energy to break the bonds, therefore they're going to have high melting point and boiling points. Ionic substances do conduct electricity, but only in certain conditions, so they don't conduct when they're a solid, because ions aren't free to move, so they're locked into place, they're not able to move around. However, when they are molten or in solution, so molten just means kind of melted, almost like lava, the ions are able to move, so they are free to move and conduct electricity. I've just got a little note at the bottom about covalent, but we'll mention that in the next video. And that's just a quick summary of ionic bonds, and we'll move on to covalent bonds in the next video.